Welcome, Algebra 1. So this is your first lecture from me, at least in this new setup. That's a little weird, huh? Basically, I'm going to be available to you guys during math lab hours, which is going to be, I'm just going to be online kind of like this. I'm going to be available. There are links in your Google Classroom showing you guys what to click. There is a password, so look at that picture in Google Classroom as well. If you guys need to come online during your normal class period and ask me questions about homework, examples, stuff that we've done, etc. That's the good time to get a hold of me. Miss you guys is kind of weird and lonely and empty in here. But at the same time, well, maybe it'll help some of us focus a little bit better. We'll see if we can get stuff done in a good way. We are in chapter 11. And as we're in chapter 11, or just starting chapter 11, you guys are working on chapter 9 test corrections. I think they're due after the weekend, right, according to our announcement. But in chapter 11, you guys have an Ed Puzzle, Khan Academy kind of intro, where he walks through some of the main concepts and main vocabulary that we're going to be going over. Just so that you guys, at the beginning of any section, I'll give you just a quick little look into what's coming. So we have 11.1a, 11.1b, and then we have a puzzle time. And so it's pretty much Wednesday, Thursday, and Friday. This video is for 11.1a. The next video will be 11.1b. Both of those homeworks are due together, as well as watching the Ed Puzzle videos. All you have to do is click on the link in Google Classroom. Make sure you're using your Heritage Warriors when you sign into Ed Puzzle. It connects the Google Classroom and that new Ed Puzzle totally together, which is awesome. And that way, when you just watch the video all the way through, when you watch this video and the next, then actually the website automatically gives you credit for that and says, good job, they finished it. All you have to do is go back to Google Classroom and hit mark is done, and you've attended class for the day. Hopefully you guys are taking notes. So we'll check those notes when this time of quarantine, social distancing, all that stuff is over. And then hopefully it'll help you too in order to be able to do your homework. We can pop in during class hours any weekday starting tomorrow in order to ask me questions if you guys are stuck on anything. I can get a whiteboard, I can talk it through with you, kind of like if you came in after school or during lunch. Or I can also pull up the textbook and we can look at homework problems too, like we would do at the beginning of a class. So those are all options that are available to you. But what these videos from now on, now that I've introduced them, these are just gonna be basically me jumping into a lesson and showing you guys the basic information, a couple examples to get you guys going on homework. So let's go ahead and do that now. That way you guys can be done sooner with this video and maybe even be able to start tackling that first homework that should be showing up in Google Classroom tonight. Tonight being Tuesday, but not due, remember 11.1, 11.1a, 11.1b, and all the Ed puzzles. So all of 11.1 are due Friday night at midnight. And then over the weekend, you just have your puzzle time that was theoretically classwork for Friday. And then your test corrections. So yeah, there you go. And you have Wednesday, Thursday, and Friday to check in with me in Math Lab if there's a question that you need to ask, or 2 or 3 or 4. So let's go ahead and see if I can get my iPad. Was being a little finicky a second ago, but let's see if it's going to be a little bit nicer and going to work a little bit nicer as well. There we go. So what I have on my iPad is I have what our textbook calls Student Journal. Student Journal is what some people do get for their Algebra 1 textbook in order to be able to let you guys kind of follow along with the lessons. There's a lot of extra stuff that we don't need that we're not necessarily going to be using. It's not bad stuff necessarily, but it is just kind of like extra. And so we're just going to kind of be going in through and hitting the highlights, hitting the high points. As I try to get my iPad working, it's kind of mean right now, or it's pretty unhappy. Let me go ahead, and what I can do for you guys is pull up your textbook and show you what we're doing and where we're going. So this is the student journal that we're going to be using to do some examples, etc., in just a little bit. And it does walk through some of the key concepts. So I'll highlight the ones that are most important. It does have a nice little note-taking with vocabulary. You guys do not need to print this out. This is just going to kind of help us stay on track as far as what's most important for a section, what we need to be doing. And then we also have the book that we might be looking at some examples. So you guys have your books at home, hopefully. And if you guys need like an online version of the book, remember I did post one of those into the class resources of your Google Classroom, but feel free to email me and I'll send you a copy or send you a link if you don't know how to do that. But we are going to be looking at some examples in the book just to kind of save time. Some of these are already worked out, but then just going a little bit deeper into the concepts that you guys understand what's going on as far as with your homework. So those are some different things that we're going to be trying to do. Let me see if I could possibly get my iPad working now. It goes in and out of working sometimes. If I can get it working, we'll go ahead and use it. And then if I can't, we might just go ahead and use my laptop instead. Let me go ahead and pause the video for a second and see if I can get. All right, guys, iPad is not going to be super happy. So instead, we're going to go about this a creative way. Let me go ahead and pull up my webcam. That's one way of doing it. And we're going to look at the iPad via the webcam. It's going to be an adventure. So as we look at the lesson, let me go ahead and try to get the webcam zoomed in so that you guys can see a little bit better what's going on. Here's that note-taking that I was talking about just a second ago as far as that cool journal. So some of the most important words that we're going to see right here in 11.1a are the ones that are on the screen right now. Let me see if I can zoom out a little bit. So the ones that are on the screen right now include, I don't need the calculator right now. There we go. The ones that are on the screen right now include measure of center, mean, median, and mode. Now there are some other ones. There's outlier and measure of variation, range, and eventually standard deviation. We're not going to focus a lot on data transformation, but the ones that are most important for part A is really just these four right here. Measure of center, mean, median, and mode. The nice thing is with Khan Academy, you guys hopefully let's see if I can get to zoom in there a little bit. See if we can get to zoom in there just a little bit more. Wow, that's not helpful. It's working well, and then it doesn't want to work. Let me try to get the light on, see if that helps just a little bit. There we go. With these four words, Khan did, I believe, did introduce at least 3 of these. And that I know that he talked about mean, I know that he talked about median, and I know that he talked about mode. The one that he didn't talk about as much is measure of center, but he did kind of talk about it. And some of the terminology that he was using as far as describing statistical data and how we talk about it. Because he was saying something like the word typical. Remember, we're looking at data, we're looking at data sets. The ones in the Khan Academy video were heights of plants, but we could be looking at anything that can be judged numerically or given a numeric value, like test scores or like ages of people in the room or in like a college class, or the number of people in different classes at school. Can be talking about how much your monthly grocery bill is, anything that can have some sort of number attached. Now we can technically collect data that doesn't have numbers attached, as in like what kind of pet do you have at home? It could be none, or cat or dog or bird or something else. So there's a lot of different things that we could gather data about. A lot of this is happening is when you're gathering information for polls, etc. But I'm not introducing necessarily all of statistics to you today. Our job is just to talk about mean, median, and mode. And when Khan was talking about that main word of typical, I'm putting it in cursive, that might not be helpful for some of you. So when he was talking about typical, what is the typical value, or what is the main value, or what is the overall value, what is the average value? There are some of these words that specifically do attach to, like the word average goes with mean. Median, if you asked your parents about the median in the road, it's that little bump or that little thing that you kind of have to jump over, hop over, that a car should never try to drive over in the middle of the road. Median is the middle. And then the way I remember mode is just because it starts with M-O. M-O is for most. It's the most repeated. It's the most repeated value. So we have these different words that Khan already introduced to you. And so what we're trying to figure out, measure of center, is which one of these for a certain data set, which one of them best describes the typical, the overall, the main value. Let's see, if we were to go ahead and look in your book as far as what this measure of center is, here we go. Measure of center is a measure that represents the center, a typical value of a data set. And then there are 3 different ways of measuring that. So all 3 of these can be measures of center, but it depends on the data set as to which one is the best one. And so that's what our job is today. Our job today is to know, okay, what is the mean? What is the median? What is the mode? What are they, and how do we find them for a data set? And then to kind of look at the data set and say which one is measuring the center, or the typical value of a data set the best? And it kind of just depends. So let's go ahead and get into an example. I'm going to go ahead and show you one that the book uses, at least as far as getting our feet wet, and then we'll go over into the student journal and try one on our own and peek at homework real fast and see if we're pretty good to go as far as the beginning of homework, which is 11.1. So just walking through really quickly, making sure that we understand what this example is doing. The data that's been given to you is over here in the table. The data is right here, the students' hourly wages. In that, of different students, it says students with a plural S with an apostrophe after. So we're measuring hourly wages of 1, 2, 3, 4, 5, 6, 7, 8 different students seemingly. Or at least 8 different jobs with 8 different pays at an amusement park. Here we go. So it could be lots of different students, but maybe multiple ones have the 825 job or the 910 job, etc. So how would we find each of these different pieces that we were just talking about? The mean, average, the median, middle, and the mode. The mean, the median, and the mode. Okay, so mean, first of all, has this special notation that you guys can see right here. It's called X bar. I think Khan introduced that. His first name is Sal, but we'll call him Mr. Khan. So Khan, I think, introduced that in that X bar is like a spiffy way of saying mean, or a spiffy way of saying the old-fashioned average. But I asked you guys a question in the video, and hopefully you were able to answer it. Average, if you're averaging like a list of things, you add them all up and you divide by however many you have. So it's pretty easy in this one, using a calculator, of course, totally fine, to add up, if you guys notice, all 8 of these values and dividing by, I just said, all 8 of the values. And so the mean, or the average, mathematically computed, is going to be 9.65. And if you look at 9.65 and the data, okay, 1650 is way higher than 9.65, but a lot of these other ones, wait a minute, if not all of them are lower than $9.65. Huh. I wonder what that means as far as how many students have these jobs and whether this truly is the average of what they're paid. And well, maybe a better way of saying this is the true average. This is the arithmetic, is what Khan said, right? This is the arithmetic mean, or the average. But remember, we're also trying to, in the back of our minds, be thinking about this measure of center, something that represents the center or the typical value. I wonder if that 965 is a good typical value for all of these students' wages. Median. All right, median is the middle, but middle, I can't see the middle unless I have them rearranged. So something key for you guys to remember that's really easy to forget is that we need to take this data that's up here in the table and we need to go ahead and rearrange it in numerical order first, and then we start counting down. We say, okay, first with last, then the second with the second last. We just start counting in, trying to get to the middle. If we ever get to, which will always happen whenever we have an even number of data points, when we ever get to a tie, meaning they both meet in the middle, the very middle would be in between, that's when we have to see it over here. That's when we have to take the mean, or the average of those two. So we kind of did a tie in the middle, and so we have to average the two. Some of you maybe can just notice, hey, between 865 and 875 is 870. But we could also do that mathematically in that, let me erase that circle, it's kind of in the way. In that when we, oh, I'm just highlighting, that's not helpful for anybody. When we add those two together and divide by 2, taking the middle, taking the midpoint, taking the average of those two values, then we get that 8.7, that will be our median. Now 8.7, still way lower than 650, but not near as far from that low value of 825 as that 965 was. 870 is at least something that seems to be in and amongst a lot of these different wages, or a lot of these different pays that the students are getting. The very last one would be the mode, if we were to keep looking. So the mode is this one down here at the very bottom. And the mode, remember we've talked about so far the mean, which is the average, adding them all up, dividing by how many. The median, we have to numerically arrange them, figure out what's in the middle, and if there are more than one, then we have to average those two. And then we have the mode. Remember, mode is for most. Mode is for most. Are any of these repeated? And the answer is yes. Only one is repeated. It's repeated twice. And so therefore, that value of 825 is the one that occurs most often. So now, as we're looking at this question, there were 2 different parts to this question. The first was find the mean, find the median, find the mode, which we did. Not thoroughly in that we got out our pencils and paper necessarily, but we did identify, at least as far as following the work, the 965, the 870, and then that 825. But if we were to look at each of those three, and if we were trying to ask ourselves the second question, which one is the best measure of center? And if we think about that word with measure of center, think about that word typical. Typical. Well, that 965 would not be a good measure because that 965 was, yes, lower than that high wage of 1650, but it wasn't really in and amongst the other wages. It wasn't really in the rest of the data. It was still outside of that data. So that 965 isn't good. That 870, we were like, okay, it's a little bit better in that it is kind of in the data. We have the 1650 that's higher, the 875 that's higher, the 865, the 910, all of these, the 925. Okay, that 870 seems to be in the middle more. And then we have one more, we have that 825. So look at that 825. Look at the data. What do you guys think? Is that a good center, a good typical value? I feel like Dora the Explorer. The answer is no. And the reason why is look at where that occurs. That occurs way over here on the left. The 965 was way over here on the right. The 825 was way over here on the left. There's so much data that it's kind of just totally ignoring. That 825 is too low in a way. That 965 is too high. That 870, kind of think like the Goldilocks and the porridge. That 870 is just right. Let's go ahead and get over, and if you guys are taking notes with us, let's go ahead and do an example. And so an example that has us finding these key concepts of mean, median, and mode, those are presented in your book as well, is this example that says, okay, extra practice. Here we go. So what if they give us our own amount of data? We have 2, 5, 16, 2, 2, 7, 3, 4, 4. It could be quiz scores. It could be how many dollars you have in your pocket when they poll you. It could be how many people are in your family or living in your home. 16, well, it's a little scary. But anyway, a lot of different things these could be representing. But for us, they're just numbers and we're just going to play with them. So we're supposed to, our objective is to find 3 different things, right? We're trying to find what is the mean, what is the median, and what is the mode. And as we've already talked about, there are meanings to each of those and what they're asking for. But for at least the median and the mode, we do need to have this data set in numeric order. So I'm going to take a second right now, and I'm going to go ahead and put it in numeric order. Now, I get a little lost sometimes with all of my data, so I'm going to go ahead and cross off the ones that I've already written down. So I have 3 2s. Ooh, I think that might be the mode. I think that might be the most repeated number. I have 3. 4 is repeated, but not as many times as the 2. I have my 1, 3, my 2 4s. I have a 5, a 7, and a 16. All right, and I've gotten all my data, and now it's in numeric order. So now as we're looking, let me go ahead and get that down out of my face. Now as we're looking at this data, let's go ahead and ask ourselves a few questions. What's easiest for us to see? Probably the mode, because the mode just says the most, and as we already noticed, the most repeated number is going to be a 2. Which, as you guys are already thinking ahead maybe to the answers, that's kind of way down here outside of all of these data points. Maybe that's not a good measure of center. Okay, then we have the median. The median is literally the middle. And so if it helps you guys, you can kind of be like, okay, that's on the outer edge, and then next comes these 2, and then we have these 2. There are different ways of counting. And then we have these 2. Hey, this time, let's check it. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have an odd number of data, and since I have an odd number of data points, there is going to be one guy alone who's in the middle, and the median is as easy as writing that guy down. In that, the median is looking for that middle guy, and there is a guy in the middle, and that middle guy is 4. That middle guy is 4. And then we have one more, and that one more is going to be our mean. And our mean is that arithmetic mean that Con was talking about that a lot of you guys have learned from a while ago, in that you're trying to add up all the values and then divide by the number of ones there are. And so I'm going to go ahead and write that in an expression. If I can get it to be pulled up. Here we go, because I'm trying to at least somewhat color code. So we have our 2 plus 2 plus 2 plus 3. Now, some of you mental mathers might be able to actually do this, plus 5, plus 7, plus 16. And this entire chapter, though, you guys will be able to, 1, 2, 3, 4, 5, 6, 7, 8, 9, you will be able to use your calculator. Remember, adding up all the data, dividing by how many there are. So even though I would normally be like, hey, that's awesome, like that's 6, and 6 and 4 makes 10, and 10 and 7 is 17, and 17 and 7 is 24, and 24 and 5 is 29, and add a 10, that's 39, and add a 6, that's, oh, I lost track. Is that 35 or 45? I was going a little too fast. You are allowed to use your calculator. Now, I'm using my big snazzy one because it's the one I have right here on the desk. But we are, once again, just taking those data points, adding them up. I trust you guys will be able to do this in your calculator yourself. I have +3, +4, +4, +5, +7, +16. It's really easy when you're adding a lot of points up to accidentally type something wrong. So I just went through really quickly and double checked I had them all. And the answer is 45 was that numerator, but we had to then go ahead and divide by 9. So this ends up being that final answer of 45 divided by 9, which is 5. Now, let's go ahead and look at each of these 3 different quantities or characteristics, maybe I should say, of the data that we were finding, the mean, the median, and the mode. We're trying to look at our overall data set up here and asking ourselves the question, okay, which one is the best measure of center? Which one gives the best typical value, just from kind of our common sense of what we see, in the numbers. And so, as I was saying before, 2 is so far away from 16 and is kind of like way off in his own little area. Sorry, my eye's watering until it's late in the day because I think I'm getting like mascara or something in there. Sorry, guys. It's not Corona. But then coming back, get a tissue real fast. As you guys are looking on the screen at those different values, that 2 is way up on the side in that 2. You guys want to see, while I'm wiping my eye, you want to see the very sad, let's see if I can switch the camera. Oh, I can't, it's not letting me. I was trying to show you my very empty, very dark room that's going on right now. But mean, median, and mode, that 2 is way far away, so the mode's not a good one. The 4 is right there in the middle of the set, but also it kind of feels like it's the middle of the values also. That 5 that you guys see is just a little bit higher, which helps account for that 16 just a little bit better as well. I think you can kind of make an argument, and I don't think you would necessarily be wrong. Remember, some of this is like a judgment call and just trying to get used to these data sets and what you would say, what you would think is best, etc. That 4 and 5 are so close to each other, I think you can make an argument for either one. 4, it's literally in the middle, and it does seem to kind of be indicative of all those different data points that are right around it. 5 is like, oh, well, you know what? It does get a bit higher. I know that there's a lot of 2s and there are some 4s, but there's that 16. You could kind of make an argument for both, but in this one, I'm pretty sure that I would go for that mode. I'm pretty sure I would go for that, that median. In that middle number, I kept saying mode, that median, because it's right there in the middle. It seems pretty indicative of a pretty typical value, a good center of what we see of most of them. Now there is this 16. There is actually a special name for the 16. I'm just going to pick a random color that we haven't been using. Let's do like purple. The 16 does have a special name that we're going to see more when we get into 11.1b. It's actually called the outlier. And if you're ever listening to anybody do any sort of statistical analysis, they might talk about like a weird value or weird values that are kind of on the outskirts of data that seem to be not typical and just kind of like some random data. Let me turn off this light webcam because it's kind of hitting the screen awkwardly. Let's see if it can still focus. So this 16 is actually what we would call an outlier, because it's like, man, everything else is, okay, the 7's kind of high, but it's still kind of close. That 16's way out there. Outlier, way out there, if that helps. But anyway, yeah, that 16 is what we call an outlier. We won't deal with him much right now today. But, ooh, hey, number 2. We're not going to solve this entire thing just because when you, I should say, are doing your homework, I don't think I gave you any outlier questions, at least not yet. So I think, let me double check. I just gave you 5 through 15 odds, and that has you stop. Oh no, there is an outlier. Okay, let's at least introduce an outlier then. An outlier, if we were to go to your textbook real fast and try to find that outlier, it's actually on another page. If I can go find it, here he is. It's a data value that's much greater than or much less than the other values in a set. And sometimes actually some data has us be honest, kind of ignore if there's one outlier, maybe two outliers that are so far off, it's like maybe something went wrong. Maybe that person answered the question falsely. There are a few other things as well. And I'll let you guys see one of your homework problems and try to figure out how you would answer that homework problem as far as what the outlier is and maybe why there's an outlier. But in this example that we're going to look at in just a second, trying to think about an outlier and trying to think about whether or not it will affect the data. I'm not going to solve the whole one that's in our practice that we were just looking at a second ago, but we can look at the one in the book for a second outlier. It's way out there, either above or below. So as we were looking at the salaries, which I guess it was up above that we already looked at, the amusement park salaries, right? The data from example 1. We had that 1650 that was so far out there. It was truly the outlier. It was way out there. It's like a random job. I don't know, maybe someone's dad owns the amusement park and gets paid that for doing something crazy. Or maybe you have like a student who's just super skilled in something random and is so different than all the rest of the students if they get a higher paying job. But it's an outlier. It is not typical in any way, shape, or form. So if we were to do our calculations all over again, ignoring the 1650, then our mean makes a little bit more sense and is kind of more typical and closer to our middle value. Our mode is still that guy who's way over here to the side just because you happen to have a few repeated ones over here. However, at least our mean and median seem to be like, okay, I can see the typical. It's somewhere right in here. And so then it makes a bit more sense about these being a bit closer together. And so down here it says like, hey, what could be one explanation? Well, in this one, a student could be hired to maintain the park's website. That's way more technical than a student that's just like watching a ride and making sure people have their seatbelts buckled, right? Or selling churros. And so the others might be paid just that more normal amount, and this one special person has to get more technical or more advanced. Okay. When we go back into the student journal, once again, we're not going to make a big deal about this one as far as solving for its mean, its median, its mode, and practice that all over again. But if we're talking about gorillas, I just want you guys to look really quickly and see, hey, do you see any outliers as far as something that's out of the norm, something that's atypical, that just doesn't seem to match the rest of them? 160, 57, 162, 158. Okay, I just jumped over it on purpose, right? It jumps off the page if you guys are just checking. If we have gorillas, if this guy's 44 and the rest of them are in like the 150s, 160s, what's going on with this poor guy? Why am I asking? Well, because I want you guys to be thinking about letter B and one possible explanation. Why would there be a gorilla that could be weighing so much less than the rest? Maybe some of you are thinking a lot of different things that feel kind of like Dora the Explorer again, as far as, hey, what do you think it is? My first inclination is, what if it's a baby? What if it's a child? What if it's a small gorilla? And now maybe you might have thought of a lot of more creative explanations. You can use that in your homework when you get to your outlier problem and what could be a possible explanation. But in my head, I was like, oh, it's just not full grown yet. It's a little baby one. So of course, it's not a great measure of how big a gorilla gets or how big all the adult gorillas are, because they measured all the gorillas, and this poor little one, well, he hasn't grown up yet. There could be other explanations as well, but let's go ahead and go look at your homework real fast and make sure for 11.1a, you guys are pretty good to go. So we're going to talk about, yes, of course, more things in 11.1b, but let's go ahead and just go peek at, you guys have 5 through 15 odds. Why am I giving the odds? I want you guys to be able to see the answers. Not to say that you can't use PhotoMath and Slater and lots of other things to see the answers all the time, but you had to work at least a little bit harder to see the evens because the odds are in the back of the book. But I want you guys to try these problems, go straight to the back of the book and know whether you're right or wrong, because that way you can just come in the next day into our online math lab via the link in Google Classroom. Signing up with Heritage Warriors, don't forget. Anything that you're signing up, Edpuzzle or Zoom, just make sure it's your Heritage Warriors email so everything's connected. You get your points better that way. But you can pop in and ask me questions if you're stuck, if you got something wrong. That's totally fine, totally cool. We're not going to be doing homework questions in these videos that I'm forcing you to watch all the way through, because some people don't need it or some people need more than others. And so I just pop on by an online math lab, okay? But looking at these odds that you have, check it. These first ones, 5 and 7 and 9, well, 9's a word problem, but 5 and 7 says find the mean, find the median, find the mode. Hey, perfect, what we just did. Determine which measure of center best represents the data. I'm just curious. I'm just curious as to what you would say and why you would say it. Number 9 gives us like a kind of like with the salaries as far as a table of all kinds of different values, but this time we're doing the lengths of movies. Now you guys can do 1 1/3 in your calculator, but it's going to be a little bit messy. So my advice to you as far as your calculator, if you're doing 1 1/3, you could figure out what, I know it's going to not like to focus. Remember, you can always get a decimal in your calculator by doing a quick little division of the top and the bottom, which is 1/3. And I'm just getting that decimal so I can go ahead and say, hey, 1 1/3 would be 1.3333. Just get a few 3s in there. You should be fine as long as you have 2 or 3 or 4. I did a few more just because I love to be precise. But you could do that for any of these fractions that you guys see. I'm not expecting you to do this by hand. Not that you couldn't. 2/3 and 1/3 is a whole one. 1/3 and 2/3 is a whole one. We just have an extra 2/3. But I don't mind if you go ahead and use your decimals in order to put those in your calculator. But then once again, measure of center. Now after we keep going, number 11 is here. To the very end of homework, we have 11, 13, and then one more kind of word problem in number 15. In stats, guys, it's a thing because we're dealing with actual situations, or at least actual data that has a meaning, and that meaning kind of even teaches us how to deal with it and deal with it carefully. That's the field of statistics, kind of is processing, displaying, being able to summarize data and being able to even predict where it might be going. Stock market. Anyway, now's not a good time to be predicting anything because no one really knows, right? God knows, and we can trust him. But let's come back to math. And so we're looking at 11, 13, and 15. So 11 and 13, they give us some interesting corrections that are a little weird. So I was thinking maybe we'd look at number 12 just to get a feel for that. And then 15, polar bears, outlier. I think it's going to be pretty similar to the gorillas questions. So let's focus on it on number 12 really fast. It's not a homework problem, but it's like a homework problem. And once we get this one done, we'll go ahead and be done with the video for today. So let me get a red pen out just because I normally do examples. And this is a little weird because it says find the value of x. Like, why is x even a part of this? Like, it wasn't in the lesson at all. Well, wait, it's algebra. X is unknown. Okay, we're missing something. What are we missing in number 12? What we're missing is one of these data points. We have 12.5, -10, -7.5. We know that the mean is 11.5. Wait, the mean. Isn't that the guy that you add everything up and you divide by how many it is? Well, wait a minute. Can't we make a little equation out of what we know the mean is and where he comes from? 11.5 comes from adding, well, what would we be adding? We'd be adding the 12.5 with the -10, with the -7.5, with the x. We'd be adding all of these guys together, and we'd be dividing by 1, 2, 3. How many data points are there? 4. Now, all of a sudden, what did seem super confusing might seem a little easier. Not that it's the easiest, but maybe it's at least easier. Remember that numerators and denominators and fractions, they do get grouped together. So I can't go tackling with addition or subtraction any of these, but I can undo the division. And so I'm going to go ahead and do it just so you guys see. Now I'm taking my equation and solving it. I'm going to multiply by 4 in order just to undo that division. I'm going to go ahead and pull my calculator up. 11.5 times 4 is going to end up being 46. And then over here, all I have left once this 4 is gone is a 1. A 1 can distribute to everything. Well, actually, hold on, parentheses. Can't I actually put all these numbers together? Can't I do 12.5 plus a -10, otherwise known as -10, plus a -7.5, otherwise known as -7.5? And I can figure out those numbers all combined to be -5. So I'm going to have -5 plus x. Well, now all of a sudden, this problem is way easier to solve. I've gotten rid of the division. I've put together any numbers that I needed to, and I can go ahead and just add 5 to both sides, and I end up with x equals 51. Well, I hope that helps. You guys need to go ahead and go tackle section 11.1a. Remember, all of section 11.1 homework you're kind of keeping together, doing part A problems first, and then there's going to be a new video tomorrow night on 11.1b that you guys can watch at any time, Wednesday night or Thursday, and then try to get all that homework, 11.1a problems, B problems, and EduPuzzle videos watched by Friday night. So I'll see you guys later. Hope you have a good night, and thinking of you and praying.